Hey everyone, it's the teaching tube, and we're doing derivatives, and we're doing it with our favorite thing. Well, okay, it's really no one's favorite. It's natural log of x. I mean, it's useful, but okay. So
what if I like natural logs?
I do too, but except for at 0 because they break everywhere, including the complex plane. Anyways, we want to take the derivative of this thing. And so there's a rule that goes with it, and what happens when you take the derivative is that you get 1 over x. Okay? Yeah. And so the reason why we don't get any weird constant factors is the same reason why when we take the derivative of e of x, we get it back. It's because e is a special number that works for calculus. Okay? There's no other good reason except that e is a special number. Okay? So let's do derivatives of e and log. Okay? So d dx of e of x equals e of x. Oh, yay. Fun. Okay.
That one's easy.
Now let's do d dx of log of x equals
Question mark.
over x. Okay.
Do you have to memorize those?
We should, because they're super easy. Okay, so now gets to be the hard part. Now, where no one explains anything, you have to do something like log base 10 of x, which isn't as nice. So, what's the strategy? The strategy is don't memorize what they give you. Only memorize this and this. Now, to figure out this thing, we know that this is equal
Are we taking the derivative of that?
Yes.
Okay.
We know that this thing is equal to, by the logarithm rules, natural log of x over natural log of 10. And the way I like to think of that, and it's not valid by any means, except it's right, is that the x is above the 10, so I just take the natural log of both. Okay? And so, if we take the derivative of this, well, we know that this thing pulls out as a scalar, so it's just 1 over natural log of 10 times the derivative of natural log of x. This equals 1 over natural log of 10 times x. This. Okay? Great. So, the derivative...
The x should be on the bottom.
Oh. Thank you.
Duh. Now that looks like it's inside the natural log. You should put it on the other side. There we go.
So,
I'm here for you guys.
Yeah. In case I make terrible mistakes. Times x. Okay, great. And remember, we can use our product rule, chain rule, everything when we take derivatives. Okay, now let's do more general exponents. So, why don't we try 5 to the power of x? Well, let's rewrite 5.
How in words? F-I-V-E.
Okay, so we write this and we remember that we want to get an E. Okay.
You're so lame.
Okay, so what we know about E and log is that we can take E and log this at the same time, and they'll cancel.
Ooh.
Great. And then, so these two cancel. And then this becomes, with log rules, you can pull exponents out. Then we can get e to the power of x times natural log of 5. Okay, and now we apply e derivatives and chain rule. So first, we take the derivative of the outside, or pretend this thing is one chunk. Okay, so the derivative of 5 to the power of x equals the derivative of this thing, which happens to be the derivative of the outside, which is e to the x log 5. Okay. So we maintain this block. And then multiplied by the derivative.
And the inside, this is chain rule, isn't it?
Yes, it's chain rule.
Which you made another video of.
In case you want to see it
You should.
again.
It's awesome.
And then this is equal to, okay, well, we take the derivative in. At least we know that one. So it equals natural log of 5 times e to the x times natural log of 5.
My magnets are in the way.
Yeah. And then if we want to be really fancy, then we can remember that the x can go back in here and that these two cancel and we get natural log of 5 times 5 to the x to the power.
That's how you do it.
And now we're done.